In this video, I'm going to talk about solving trig equations. So solving trig equations. We're not going to be using the calculator for these problems, so this is going to be no calculator solving trig equations. And the next time I see you, we'll talk about how to solve trig equations with a calculator. All right, introduction. So the goal for these problems is to isolate the trig function and then solve. So just like we isolate x, we're going to isolate the trig function, and then we're going to have to use what we know about inverses to solve. So we're going to isolate the trig function. Whoops. Then solve. For the examples that you'll see, it'll tell you to solve. And here's one example. Maybe I have 1 minus 2 cosine of x is equal to 0. First thing I would do is I want to isolate that cosine of x. I want to isolate the cosine of x. So first thing I'm going to do is I'm going to subtract 1 on both sides, and that will get me negative 2 cosine of x is equal to negative 1. And then I'm going to divide by negative 2, that coefficient on both sides, and I'm going to get cosine of x is equal to 1/2. Then I want to think about the unit circle. So I know cosine of x is equal to 1/2. I know x is some angle. And I know 1/2 is one of the things on my unit circle. It's one of the coordinates on my unit circle. So I'm going to draw a little unit circle over here. And one of the points that I have in the first quadrant will have cosine is the x value on the unit circle. So I'm looking for when the x value is 1/2. So I have the point 1/2, comma square root of 3/2. I also have a positive 1/2 in the fourth quadrant. So positive 1/2 in the fourth quadrant. And that's for y, negative square root of 3/2. I know this angle for that point is pi/3, or 60 degrees. And I know that this angle is negative pi/3, or on the unit circle it is 5 pi/3. What I'm going to do is I know that I could either have it in the first quadrant or the fourth quadrant where cosine is positive, or where the x value is positive. And I'm going to say that x could be equal to pi/3, or x could be equal to 5 pi/3. Now, I can write these. What I need to include in my answer is all the coterminal angles. So all the angles that are included that are coterminal to this angle here and this angle here. And the way I find coterminal angles is I add 2 pi. So how I'm going to write my answer is pi/3 plus 2 pi times n. So n would be whatever number I want it to be. And then the other one, I write the same thing, 2 pi n, and that includes all of the coterminal angles. All of the coterminal angles. Okay, 5 pi/3 is not a coterminal angle for pi/3. All right, let's do another example. So second example, maybe I have sine of x plus 1 is equal to negative sine of x. For this, the first thing I'm going to do is I'm going to add sine of x on both sides. I'm going to add sine of x on both sides, and then I'm going to subtract 1 also. So add sine of x and subtract 1. And I'm going to end up with 2 sine of x on the left-hand side. The ones are going to cancel each other out and equal 0. And on the other side, the sine of x's are going to cancel each other out. And then I have negative 1. Last thing I do to get sine of x by itself is divide by 2 on both sides. And I get sine of x is equal to negative 1/2. Again, I'm going to use my unit circle. And I know my sine is y on the unit circle. So I'm looking for the points on the unit circle where y is equal to negative 1/2. So that would be in the third quadrant, and that would be in the fourth quadrant, where y is negative. I have the point negative square root of 3 over 2, negative 1/2. And I am also at the point square root of 3 over 2 and negative 1/2. The angle for this point here, the angle, so that's the angle going from here to here. That angle is 7 pi over 6. So that's one of my answers. And then this angle here, that angle is 11 pi over 6. So I have two answers here. I have x is equal to 7 pi over 6, and I want to include all terminal angles. So I put plus 2 pi times n being any number that I want it to be. Or I can say that x is equal to 11 pi over 6 plus 2 pi n. So these are my two different answers. Okay, let's do another example. So maybe I have tangent squared of x minus 3 is equal to 0. First thing I'm going to do is I'm going to add 3 on both sides. And then I have tangent squared of x is equal to 3. Because I want tangent of x by itself and I have tangent squared of x by itself, I'm going to take the square root of both sides. So that on the left-hand side I have tangent of x is equal to, and then I have when I take the square root myself, I need to include both plus and minus. So plus or minus square root of 3. For this, I know I am, because I am including positive and negative square root of 3, I am in every quadrant. Every quadrant works. So I'm going to talk about just the first and second quadrant because I can write all of the possible answers just using the angles I get from the first and second quadrant. So I'm looking for where tangent of x is square root of 3, which means I want the y over the x value to be the square root of 3. So I want the y value with the options that I have. I have 1/2, I have square root of 3 over 2, I have square root of 2 over 2, 1 and 0. And I want to use two of those that go together on a point to get me a square root of 3. And that would be where y is the square root of 3 over 2 and x is 1/2, because if I divide those two, I'm going to get the square root of 3. So I want the x value to be 1/2, and the y value to be square root of 3 over 2. For this one, that's for positive square root of 3, and then for negative square root of 3, I would have negative 1/2 and square root of 3 over 2. This angle here is going to be, that angle there is pi over 3. And then this angle going to that terminal side is going to be, that angle is 2 pi over 3. I can write my answers as x is equal to 2 pi over 3 plus, now that I have both positive and negative square root of 3, I'm not going to add by 2 pi n. I'm going to add by pi n because I know that that will include everything. So for that 2 pi over 3, I would also be including pi away here at 1/2 comma negative square root of 3 over 2. And then adding pi again, I would get back to here, and then adding pi again, I would get back to there, and I would keep going. So instead of adding, when I have a positive and negative answers, when I have something like that, I am adding pi n instead of 2 pi n to each of my answers. So this is my first answer. And the second answer is pi over 3 plus pi n instead of 2 pi n. So example 4 is going to be a little bit harder. I have secant of x, cosecant of x is equal to cosecant of x. One thing that you're going to want to do but you can't do, and this is really important, is you cannot divide by a trig function. And the reason why is because you do not know if that trig function is 0. So here you might want to divide both sides by cosecant of x, but you can't because you don't know if that's equal to 0. In this particular case, cosecant cannot be 0 ever, so you could divide by cosecant on both sides, but just you are not allowed to divide by trig functions because you don't know if they're 0 and you can't divide by 0. So what I'm going to do instead is I'm going to subtract cosecant of x on both sides. I'm going to get secant of x cosecant of x minus cosecant of x is equal to 0. Then what I'm going to do is I see that both of these terms share a cosecant of x in common, so I'm going to take that out. So I have cosecant of x times secant of x minus 1 is equal to 0. Then I'm going to use the product property, the zero product property, sorry. The zero product property says that if I have a times b is equal to 0, then either a is equal to 0 or b is equal to 0. This is from back in Algebra 2, we did this. So I can say that cosecant of x is equal to 0 because one of these two things has to be equal to 0. Either this is 0 or this is 0. So I know cosecant is equal to 0 or secant of x minus 1 is equal to 0. Cosecant of x cannot be equal to 0. This is undefined. There is no angle where you get cosecant of x is equal to 0. If you think about the unit circle, a cosecant is h over, so it's hypotenuse over opposite. And the hypotenuse is 1. So you can't make that equal to 0, no matter what the denominator is. And so that's undefined. So I'm focusing in on the second equation. So I'm just going to ignore this one. I'm going to focus in on the second one. I'm going to add 1 on both sides. I get secant of x is equal to 1. And then I am going to figure out what cosine would be, because that's what's on my unit circle. So I'm going to use the unit circle for these because there's no calculator. So I know if secant of x is equal to 1, that's 1 over 1. And then if I wanted to find cosine would also be 1 over 1 or 1. So that's what I'm going to use. On the unit circle, I'm going to find where do I have my x value is 1. I only have one place on the unit circle where x is equal to 1, and that is the point 1, 0. And I know that that angle is equal to, it's equal to 0. So I know that x is equal to, I would write 0 plus 2 pi n to include all coterminal angles. Or I just say x is equal to 2 pi n. And that's my answer. For example 5, I have cosine of x minus the square root of 3 is equal to negative cosine of x. And I'm going to specify that my answer, so sometimes it'll specify that your answer needs to be in the interval, and it'll give you a range of values that the angles can be. So it might say 0 to 2 pi. So then you have to find just the 1 or 2 places on the unit circle that fit the answer or fit the equation. First thing I'm going to do on both sides is I'm going to add cosine of x. So I'm going to add cosine of x on both sides, and I'm also going to add square root of 3 on both sides. That way I get all of my constants, not constants, but regular numbers on one side and all my trig functions on the other. I'll have on the left-hand side 2 cosine of x. The square roots of 3 cancel each other out. And then on the right-hand side, I have the square root of 3. Now from here, I'm going to divide both sides by 2. And I'm going to get that I have cosine of x is equal to square root of 3 over 2. Now, I know if I'm thinking about my unit circle, I am looking for the point where cosine I know is x. I'm looking for the point or points where x is positive square root of 3 over 2. So I have the point square root of 3 over 2, comma 1/2. And I also have the point in the fourth quadrant where x is positive square root of 3 over 2 and negative 1/2. So I have these 2 points. For this angle here, I know that angle is going to be pi over 6. That's 30 degrees. And I know for this angle here, that angle is going to be 11 pi over 6. So I have 2 answers here. Only 2 answers because I am only including the answers that are in between 0 and 2 pi. So I'm going to say x is either equal to pi over 6 or x is equal to 11 pi over 6. And those are my only 2 answers. And I don't include all the coterminal angles because it's specified I had to be in between 0 and 2 pi. Example 6. So for example 6, I have 2 cosine squared of x minus 1 is equal to 0. I am going to add 1 on both sides here to start. I will get 2 cosine squared of x is equal to 1. I'm going to divide both sides by 2. I'm going to get cosine squared of x is equal to 1/2. And then I'm going to, because I want cosine of x by itself, so I want cosine of x by itself, I'm going to take the square root of the left-hand side. What I do to the left, I have to do to the right. I'm going to get square root of 1 over square root of 2, so that's 1 over square root of 2. I'm going to edit this a little bit by multiplying by the square root of 2 over the square root of 2 because I don't want square roots in my denominator, and I get square root of 2 over 2. So cosine of, I forgot to include the positive and negative because I took the square root. So don't forget to include, when you take the square root yourself, the positive and the negative version. So I have 2 things here. Again, like I did last time, I saw both the positive and negative. I'm focusing in on my first and second quadrant. First and second quadrant where I have the x value is square root of 2 over 2. So I have this point here in the first quadrant, and I have negative square root of 2 over 2, comma square root of 2 over 2 in the second quadrant. For this angle here, I know this angle is pi over 4. And I know that this angle here is 3 pi over 4. So this angle here is 3 pi over 4. Oops. I want to include, so I want to write that x can be equal to, I have pi over 4 plus 2 pi n, so that includes all coterminal angle. Oh, no, sorry, not 2 pi n. If I add pi to this, I'm going to be at the point here where it is negative square root of 2 over 2, negative square root of 2 over 2. And then if I add pi again, I'll be back there. And if I add pi again, I'll be back there. So instead of writing, when I have positive and negative answers, instead of writing plus 2 pi n, I just write plus pi n. So that is one of my answers. And then the other answer is x is equal to 3 pi over 4 plus pi n. Again, same thing. And these are my 2 answers. And then for example 7, I have 2 cosine squared of x is equal to 3 cosine of x. And I need to remember, do not divide by a trig function, so do not divide by cosine here. Because you don't know if it's equal to 0 and you can't divide by 0. So what I'm going to do is I'm going to subtract 3 cosine of x on both sides instead. I'm going to end up with 2 cosine squared of x minus 3 cosine of x is equal to 0. I'm going to factor out what I can. So I know that I have a cosine of x in common here. I'm going to factor out cosine of x, and I'll have 2 cosine of x minus 3 is equal to 0 when I factor out the cosine of x. So I can say that cosine of x can be equal to 0, or by the zero product property, I can say that 2 cosine of x minus 3 has to be equal to 0. One of those two things has to be equal to 0. For that second fraction, I'm going to add 3 on both, that second equation, I'm going to add 3 on both sides. I get 2 cosine of x is equal to 3. I'm going to divide both sides by 2, and I'm going to see that this ratio doesn't fall where it should. So cosine ranges from -1 to 1 as for the ratios. Because this is 1.5 and that's more than 1, I say this is not in the range for cosine of x. So this I'm going to ignore, and then I'm going to focus in on this here. On my unit circle, I'm looking for where I have a point. Oopsies. I'm looking on my unit circle where I have a point where x is equal to 0, and that is here. So I have 0, 1, and I also have 0, -1. This angle here is, this angle here is pi over 2, that angle. I can write, if I just keep adding pi each time, so going pi each time, instead of adding, also including that this angle here is 3 pi over 2, I can just say, in one short thing, I can just say x is equal to pi over 2 plus n pi. Since those are pi away from each other, and if I keep adding pi, I'm going to have a bunch of all of the possible answers. All right, let's try equations of the quadratic type. So we'll do equations of the quadratic type. So this is just going to be a little bit different, same concepts. You're just going to have to do a little bit more to solve. So example 8, maybe you see something like this. 2 cosine squared of x plus cosine of x minus 1 is equal to 0. Maybe you see something like this. And then you're told that it's on the interval 0 to 2 pi. So your answers for your angle answer has to be in between 0 and 2 pi. What I want to do is I want to, because there is something in front of the x squared term, the squared term, I have to use the diamond to go to expanded form. So I'm using the diamond. I need two numbers that multiply to -1 times 2. That's a times c, which is -2. And I need them to add up to 1, the coefficient for that middle term, or the cosine of x to the first power. And those two numbers are 2 and -1. That tells me how I can split this middle term. So I can split that middle term into 2 cosine of x minus 1 cosine of x, or just minus cosine of x. And then I'm just going to bring down the other terms. So I have 2 cosine squared of x plus 2 cosine of x minus cosine of x minus 1 is equal to 0. Now there are two ways that I can do this. I'm going to do this example using the area box. So I know that I have 4 terms now, and they can go in for the areas. I put the squared term here, so cosine 2 cosine squared of x goes there, the constant goes here, it doesn't matter where the other two go, and then I find the side lengths. So the only possibilities for me to get 2 cosine squared of x is to multiply 2 cosine of x times cosine of x. I have to put them like that or it won't work. And then I do cosine times what gives me negative cosine of x, and that's -1. And then I do 2 cosine times what gives me 2 cosine of x, and that is +1. So now I know that I can break this down into 2 cosine of x minus 1 times cosine of x plus 1, and that's equal to 0. by the zero product property rule, I can say that 2 cosine of x minus 1 is equal to 0, or cosine of x plus 1 is equal to 0. I'm going to solve these two equations now. So this just gets a little more complicated. It's just a little more work. I have 2 cosine of x is equal to, but now, it's just a little more work when I'm back where I was before. Equations I needed to solve. I have 2 cosine of x here is equal to 1, divide both sides by 2. I get cosine of x is equal to 1/2. So that's one of my equations that I'm going to need to solve. And then the other one, I'm subtracting 1 on both sides. I'm going to get cosine of x is equal to -1. And I'm going to now use my unit circle to figure this out. So my unit circle off to the side. I know that for cosine of x to be positive 1/2, my x value needs to be 1/2. So I have two options here. 1/2 square root of 3 over 2 is the point, or 1/2 and negative square root of 3 over 2 is the point where x is positive 1/2. I also am looking at where x is -1, so that's here, -1, 0. For this here, I know that the angle is equal to, that angle is pi over 3. I know this angle here is pi, and I know that this angle here is going to be 5 pi over 3. So I know that my answers are x is equal to pi over 3 and 5 pi over 3 from the first equation. So that's from the first equation. And then from the second equation, I can say x is equal to pi. And I'm not including coterminal angles, I'm only including angles that are on that interval from 0 to 2 pi. And then let's try, let's just do one more. So let's do example 9. I have maybe I have 2 cosine squared of x plus 3 sine of x minus 3 is equal to 0. And then again, on the interval from 0 to 2 pi. Okay. First thing I want to do is I want to get this all in terms of one trig function. So I don't want cosine and sine, I just want one or the other. I can, using one of my Pythagorean identities, rewrite cosine squared of x in terms of sine of x. So off to the side, I know that I have cosine squared of x plus sine squared of x is equal to 1. If I subtract sine squared of x on both sides here, I can see that cosine squared of x is equal to 1 minus sine squared of x. So I am going to rewrite this as 2 times, instead of cosine squared of x, I'm going to write 1 minus sine squared of x. And then I have plus sine of x minus 3 is equal to 0. And then I'm going to distribute. So I get 2 minus 2 sine squared of x plus 3 sine of x minus 3 is equal to 0. I'm going to now combine my like terms. So I'll have negative 2 sine squared of x plus 3 sine of x minus 1 is equal to 0. And then I want a positive number in front of my sine squared. So since this is an equation, I'm going to multiply everything by -1. And I'm going to get 2 sine squared of x minus 3 sine of x plus 1 is equal to 0. And then I'm going to use the diamond to solve. So I'm going to do this in a little bit of a different way. I'm not going to use the diamond to area square. I'm going to use the diamond to grouping in case you like that method better. So you can see both. I still need to use the diamond and multiply a times c to find what I need the two numbers to multiply to. So that is 2 that I need them to multiply to, and I need them to add up to -3. and those two numbers are -2 and -1. So I can break down this middle term to be -2 sine of x minus 1 sine of x, or just minus sine of x. So I have 2 sine squared of x minus 2 sine of x minus sine of x plus 1 is equal to 0. And then from there, I'm going to do grouping. So I'm going to focus in on the first two terms and take out the GCF. And then I'm going to focus on the second two terms and take out the GCF. I'm going to see that they have something in common. So for the first pair there, I can take out 2 sine of x. So I can take out a 2 sine of x, and I have 2 sine of x times sine of x. Minus 1 is going to be what I get there. Plus, if I take out a negative, I want to get the same thing here. If I take out a -1 and I have -1 times sine of x minus 1, I can see that these two pairs of numbers or terms have something in common. Sine of x minus 1 is what they have in common. So I have 2 sine of x of that, and I have -1 of that. So I have a total of 2 sine of x minus 1 of sine of x minus 1. And now I know this is equal to 0. I can use the zero product properties to say that 2 sine of x minus 1 is equal to 0, or sine of x minus 1 is equal to 0. I'm going to add 1 on both sides here. I'm going to get 2 sine of x is equal to 1, or, I'm going to divide both sides by 2. I'm going to get sine of x is equal to 1/2, or I'll add 1 on both sides here. I'll get sine of x is equal to 1. And I'm working with these two equations, so I'm going to use my units. I'm going to use my unit circle, and I know that I am focusing in for this. I'm focusing in on where y is positive, so that's here and here, and it's for the point where I have the y is 1/2, so that's square root of 3 over 2 1/2, negative square root of 3 over 2 1/2. I also want where the y value is 1, so that's here at 0, 1. This first angle here, that angle here is pi over 6. The second angle going up here, that's pi over 2. And then this angle going to there, this angle is equal to 5 pi over 6. So my answers, I have x is equal to pi over 6 and 5 pi over 6 from that first equation, or x is equal to pi over 2 from sine of x is equal to 1. And those are all my options. And I don't include the coterminal angles because it specified that the angles needed to be within this interval.